Okay guys, this should be the last video for Unit 7. This video is going to cover molecular formulas and empirical formulas. So first, some vocabulary. What is the molecular formula? It is the true formula of a molecule. So that one's going to have higher subscripts than the empirical formula, because the empirical formula is the lowest whole number ratio of atoms, and it can represent several different atoms. Let's make sure we understand that this one can be several different things. Now, ionic compounds will only have an empirical formula, and they won't have a molecular because those have a crystalline form and they always exist in those ratios. Let's keep on going. Let's solidify more information. What do subscripts represent in the molecular formula? It represents the actual number of atoms in the molecule. So if I give you glucose, C6H12O6, that molecule has 6 carbons, 12 hydrogens, and 6 oxygens if that's the molecular formula. So the subscript for the empirical formula is the lowest whole number ratio. We'll show you what that looks like in a bit, but basically it's going to be, we can divide 6, 12, and 6 by 6. We get C, H6, oops, H2. Oh, that would be the empirical formula. Because you see, the molecular formula always has higher numbers, and they always can be divided by a common number to become that empirical formula. So let me get this out of the way. So the molecular formula of glucose, like we were just working with, and the empirical formula is CH2O. How many empirical formulas are needed to make the molecular formulas? We remember we're going from 2 to 12. There's a common number there. How do you go from 2 to 12? You multiply everything by 6. So there are 6 empirical formulas needed to make the empirical formula. So what is the molar mass for the empirical formula, and how does it relate to the mathematically to the molar mass of the molecular molecule? Then it's a lot of words. Just to say, CH2O has a molar mass of 30.3 grams. And how does it relate to the mass of the molecule? Well, remember we just said that there are 6 empirical formula units in every 1 molecular unit for this particular molecule. So we take 30.03, we times it by those 6, and that's going to give us 180.18, which will be the molar mass for the entire molecule, C6H12O6. So I hope you are seeing the mathematical relationship between the empirical and molecular formula, because you're going to be using that a lot very soon. Now you have steps for doing empirical formulas. Make sure you know these steps, because you're going to use them a lot, and if you don't know the steps, you're not going to be able to do anything. So the first step, percent to mass, is always assume 100 grams. This part's easy. You just drop the percent label and add the grams label. So 42% becomes 42 grams. That part's easy. Next, convert mass to mole, which basically means divide by molar mass. For each element. Step 3, divide by smallest. You're going to get an answer when you divide all those elements by their molar masses. You take the smallest answer and divide all the other answers by that smallest answer. That will make more sense when I show it to you in an actual problem. Then you multiply it to a whole. Sometimes you don't have to do this part, but sometimes they end in weird, funky numbers, and here's your little chart. That should help you out, but they have to be whole numbers, because you can't have a decimal subscript. That doesn't make any sense. So here's a little here's a little helpful hint. If it ends in 0.2 or 0.8, make sure you write this down. It's not in your notes, but you're going to need it. Multiply the ending subscript by 5. If it ends in a quarter, so 0.25 or 0.75, multiply by 4, and then so on and so forth. You can read that for yourself. And you will use those, so make sure you write those down before we go on. So memorize this saying. You're going to hear us say it a lot. So percent to mass, mass to mole, divide by smallest, multiply till whole. It has a nice little rhythm, nice little rhyme to it. Make sure you can do it in your head, because those are the steps. And if you know the steps, you know the rhyme, these are very easy, but they do take a lot of work. So let's do our first one. The compound is found to have all that stuff in it. What is the empirical formula of the compound? Let's start with the first step. We have zinc. Zinc has 34.39%. So remember, we just mark out the percent sign and say 34.39 grams. Nitrogen has 14.82. Mark out the percent sign, turn it into grams. 14.82 grams. And finally, we have oxygen. Just drop the percent sign. That's 15.79 grams. All right, so that was our first step, percent to mass. Now we're going to go mass to mole, which means divide by the molar mass. So make sure you get your periodic tables. so you know where we're getting these numbers from. Molar mass for zinc is 65.41. That gives us an answer of 0.5258. Molar mass for nitrogen is 14.01. You divide those, and that gives us 1.05758. And molar mass for oxygen, should have that one memorized, 16, and that gives us 31744. So that was step 2, percent to mass, mass to mole. Now we're going to divide by smallest. So you got to look at these three answers and decide which one is the smallest. And that one should be easy. It's going to be the 0.5258. That's our smallest. So we're going to divide all of these by 0.5258. So the first zinc equals 1, nitrogen equals 2, and oxygen equals 6. So now these become subscripts. So zinc is the 1, nitrogen is the 2, and oxygen is the 6. Now, normally don't do the 1, so it's just Zn, N2O6. And that's your final answer. See that these become the subscripts. All right, let's go on to the next question. Now we have a 200-gram sample, which means first you've got to find the percentages. So to find percentages, I teach you guys how to cross multiply and divide, which means we're going to have to do, well, let's just start off like this. We'll start with carbon. Carbon has 94.74 grams out of every 200 grams, so 94.74 grams out of a 200-gram sample. We need to find out what percentage that is over 100. So you cross multiply and divide. So it's going to be 94.74 times 100 divided by 200. That's your cross multiply and divide, and that gives you 47.37%. Which means we have 47.37 grams for carbon. The next one is hydrogen. You can do the same thing for hydrogen, 21.05 over 200 equals x over 100, and you'll get 10.5% hydrogen, or 10.5 grams of hydrogen. And oxygen, you do 84.21 times 100 divided by 200. Just do that cross multiply and divide again, and that will end up giving you 42.105% oxygen, or grams. So now that we've done that first step, now we've got to do mass to mole, which just means divide by the molar masses. So carbon is 12.01, which gives us 3.9442. Hydrogen is 1.01, there's a decimal there, and that gives us 10.36. And then oxygen finally is 16.00, and that will give us 3.5058. All right, so now we got to do divide by smallest. Which is the smallest? It's 35058 right here. So we divide all these by 3.5058. And that gives us 1.1. Divide by 3.5058. And that gives us 2.9. Divide by 3.5058. And that gives us 1. So now we have a 0.1 and 0.9. Remember, those are not on our charts. We just go ahead and round those. 1.1 goes to 1, 2.9 goes to 3, and the 1 stays at a 1. So now these become our subscripts. We have carbon, which is 1, a hydrogen with a 3, and oxygen with a 1. So CH3O. And that's all there was to it. Just make sure you can find those percentages from the given mass. And make sure if they give you a mass of the sample, you know how to cross multiply and divide to get the actual percentage. Now let's go on. So now we're going to do molecular formulas. So the first step, find the molar mass of the empirical formula. So you might have to go through all those steps just to find the empirical formula, and then you've got to find the molar mass of that empirical formula. Step 2, divide the molecular mass. That's always going to be given in the question by the entire molecule. So molar mass of the molecule by the molar mass empirical formula. This number will give you your EFUs, which are called empirical formula units, and that will give you a single whole number. You multiply all the subscripts inside of the empirical formula by your EFUs to get your new subscripts. It sounds like a lot of work. That part's actually easy. So here's our practice problem. If empirical formula with a substance we determine, here's your molecular formula, C2H4O2, and here is your molar mass for that. So determine the molar mass or molecular formula for the substance. Alright. So now I have an empirical formula, C2H4O2, and a molar mass of 132.16. Determine the molecular formula. Okay, so first thing we got to do is find the molar mass for our empirical formula. C2H4O gets a molar mass of 44.06. So now we do the molar mass of the molecular formula over the molar mass of the empirical formula. So remember, this one's always given, and it's given right here, 132.16. You divide that by the molar mass of the empirical formula, right here, 44.06. That gives us 3, which means we have 3 empirical formula units, 3 EFUs. So now you take that 3 and you multiply it by each of the subscripts in the empirical formula. So 2 times 3 is 6, so C6. 4 times 3 is 12, so H12. And 1 times 3 is 3, so O3. C6, H12, I'm sorry. C6, H12, O3. Sorry, kids, give me one there. And that's our final answer. Alright, so the empirical formula for a carbohydrate is CH2O, and its molecular mass is going to be 240. What is the molecular formula for the compound? Well, so here we go. CH2O. First, you got to find that molar mass, which equals 30.03 grams per mole. So then you do the molecule's molar mass, 240, over the empirical formula's molar mass, which is going to be 30.03, which gives you 8 empirical formula units. You take that 8, multiply it by the subscripts in the empirical formula, you get C8H16O8. See, these aren't too bad. Now, if the empirical formula for hydrocarbon is known to be containing that much, and its molecular mass is known to be 78 grams per mole, what is the molecular formula for the compound? This one you got to do a little reading into the question. Hydrocarbon. That means it's got hydrogens and carbons. But it only tells us that it's 92.3% carbon. So 100 minus 92.3 is 7.7% hydrogen. So now we got to do all the steps. Carbon is 92.3 grams. We're going to just drop the percent off. Hydrogen is 7.7 grams. Mass to mole divided by their molar mass, 12.01 and 1.01, which gives us 7.69 and 7.62. Next step, divide by smallest, which is 7.62. So this one equals 1. The one above it also equals 1 with a negligible decimal point after that. So our empirical formula is CH equals our empirical formula. So now we've got to find the molar mass of CH, which is 13.02 grams per mole. And then we can take our molecule, or molar mass of the molecule of 78. So use 78 divided by 13.02, which gives you 6 EFUs. And then you times them by the subscripts in your empirical formula. So you get C6H6 as your molecular formula. That one was pretty easy. And that's all there is to it. And you'll get a lot of problems with these, a lot of practice with these in class, so don't freak out. I know it's a lot of work, but I hope you see the work is not difficult as long as you follow the steps. That's it. We'll see you guys in class.